Testing. Oh. There. Test. Testing 1, 2, 3. Testing 1. Okay. Testing 1, 2, 3. Testing 1, 2, 3. Test. Okay, great. Well, we'll switch over to split screen new space. Sorry for the delay. I never remember how to turn those off if I'm supposed to do it over here or there, but if I turn it low on there, this mic doesn't work, so I just unplugged them. But I gotta remember maybe to talk to someone who does know, because the next person who has to use those won't know that they're unplugged for 30 minutes until they go over and look, and then they've been messing with that. Okay. So we've got Calgary joining us today. They've heard the testing, so I think we're ready to start up. I don't know about all of you. This guy's supposed to make us anxious, right? Like, we're supposed to feel that way. Everyone feels that way about this character, right? Yeah. Okay, because the memes just, I can avoid them. I would love to avoid them. Sorry about that. Let's just go through this a little bit. It's Monday, right? Monday is, we're going to do some new stuff this week. And that's going to happen every Monday for you. Every day as well, but to a greater extent, it's the Mondays where we really start to feel it. And so this week, Asynchronous flow is what we're after, but that's not quite today. Today we're going to talk more about testing, but this week is about how do we handle asynchronous control flow in JavaScript, and we do that through the use of different techniques, and we'll learn a few of them, actually. So some older techniques like using callbacks, and some newer techniques like using promises. What else? You could read all that. And I really recommend reading these things when the week starts, at least, because it really tries to prepare you for what's coming up. And I feel like knowing what's coming really helps me learn stuff. So please, for your sake, read these. And today, we're going to talk about how do we test our code. So in preparation for starting to write some more complex code, we want to start to learn how to test the more complex code. And so for that, we're going to use a more automated system. And what automated testing gives us is it's a consistent way to run the same tests, right? We can run the same tests. Everyone who's working on a project can just run the same tests, and your code, all that code gets tested the same way every single time. Whereas if you have a number of people working together on a project, and they all decide what testing that project is independently, then maybe sometimes you get good testing, and sometimes you get not so good testing, and usually you end up somewhere in the middle. But what you really want is predictable, consistent testing. That is the goal of a productive software team. So today we're just going to introduce ourselves to that a little bit. We're not going to be doing it in a group, but think that this really just helps us with more complex code. And we're going to be sticking to code that you know today so that we can focus on the testing aspect of it. I don't want to present anyone with a problem like a function to write today that they wouldn't be able to do. Most of the code we'll write today came from last week, but we'll add a layer onto it, potentially even writing the test before we write the code that proves that the test does its job. And that would be called test-driven development, even though I'm not going to focus on that today. Again, that's where we ultimately might want to end up. For myself, personally, if we talk about test-driven development, I do it sometimes. And I really choose based on the thing I want to build. So I won't be able to tell you until I have to write some code whether or not I want to do automated testing on it, up front or afterwards or at all. But hopefully over this program, you start to get that feeling yourself. Because what I don't want to see people doing is, one, being low confidence in their code, having very little confidence in that their code works the way that it's meant to. We can't move into the next stages of our career if that continues, but we can learn how to get away from that through proper testing. Yeah, so you'll be testing, I think, a little bit of the low tide stuff this week, so that's kind of cool. So testing some library code. Pair programming today, that's pretty exciting. Anybody not know what pair programming is? Can I get a thumbs down in Calgary if no one knows what pair programming is, but a thumbs up if everyone knows? I mean, we're going to be pair programming. I don't know what a pair with 25 people or something in it is, but we do that every time I stand up here, right? You notice errors in my code as I type something incorrectly. You see it before I do. You let me know about it. And we're just moving along together, making more progress as a group than we would independently, right? And so great. So everyone in Calgary is on with pair programming, and get used to this. It's not only that, it's fun because pressure's not all on you. You can share that pressure, and when a team shares pressure, we can do pretty great things. So yeah, make your teams today and use them to your advantage and help each other. It's great. Okay, so the lecture today, we're going to prepare ourselves for test-driven development with Mocha and Chai. I said we wouldn't talk about test-driven development much. That's until I read this, right? And then I know really what I want to cover. And that's cool. Actually, I really want to talk about test-driven development because I think that it is a useful process when you're kind of unsure about what you're doing. So maybe that's how I will actually present it to you. That would be good. We're going to use Mocha, which is one of the tools that we'll introduce. I think we've introduced on the weekend in the rating. OK, good. So I'm not introducing it, but what is Mocha then? What is the purpose of a tool like Mocha? if something were to run our tests for us, we would call it a test runner, maybe. Actually, I hope we do. We actually call it a test runner. Kind of a cool name, but it's any sort of piece of software that's going to be running a suite, S-U-I-T-E, of tests. So we'll have our suite of tests. It's a collection. And our test runner, Mocha, is going to go through that and run each one and then provide feedback to us on green is good, red is bad. This is the test that failed. Hopefully you've given that test a good description so you know exactly where the code is or what the problem is. So that's what Mocha does for us, is it is our test runner. And Chai. So Chai is not a test runner because we already have one. There are others. Other than Mocha, we have other test runners. If I were to do a search, I think we get names like Ava or Ava. I don't know how they want us to pronounce it. Test runner JavaScript. There's Mocha for sure. That's what I mean. It makes sense. This is the most popular one out there. And a lot of tools that are coming out these days are built on top of Mocha. So Mocha is very popular. I use Jest. Now I say Mocha is popular. I use Jest. I believe Jest is built on Mocha, and actually probably all of them are built on top of Mocha in some way or another. But maybe what someone has done is presented the output in a different way. So they're like, well, Mocha does most of what I want, but I'm going to build something on top of it that does a little more. I'll include some test coverage support in there as well. So my test runner does a little bit more than just running tests. That would be something like Jest, building on those shoulders of previous software, right? Ava, another one. So our test runner, that's not what Chai is. Chai is an assertion library. So Chai gives us the ability to claim that things are true, right? That's what an assertion is. And this is very useful because in our tests, we have 3 stages. We start off by setting up our code. Right? We say, well, we have a function over here, so we need to import that or just declare it somewhere. So we got this pre-existing system, and then we have some change that we want to produce in that system. And then after that change happens in the system, we want to test that what we expect to happen actually happened. And so that expect part at the end, the third stage where we verify that everything's working well, we use our assertion libraries for that, and we assert that the return value of a function is 3, or that it says hello world, or whatever the function is meant to do. We can assert that it does that, and when it doesn't do that, our test runner tells us. So that's how these 2 tools work together. And what Chai allows us to do is makes it a lot easier to assert on some more complex things. So right now we're going to be pretty limited in what we assert on. It will allow us to use a bit more of an English language in the formation of our assertions. But later on, if we wanted to test our web servers, for example, Chai has something called a plugin where you bring that in, and now you can expect that your web server returns a certain status code. And it just makes it easy to write that code. You don't even think too hard about that. But Chai goes on and on and on in trying to make your life easier to assert that certain parts of your code are acting in a certain way. Let's also do, here we go, last little bit. While we do all of this, yes, question, great.
So does that mean that it can describe or not that
Yeah, so the question is, are it and describe Mocha? Yes. The test runner provides this infrastructure for us to write our tests in. So we describe our test suites in files, and then within our files we can describe different sections, and then we can even do subsections if we want with more describe blocks. But then at the end we put an it or a test, and that is our actual test function that runs. Each one will run individually. But then when it comes to Chai, so we expect, or the code should, or I think there's a third one. I think it's just assert. We'll look at those when we go to them. But that's exactly right. Yes, describe and it are part of Mocha, whereas assert and expect and those types of things are Chai considerations. Okay, so as I go through, I'm going to be creating and consuming modules using Node's default CommonJS syntax. That's a lot to say. Let's do that. Let's talk about that one more time. But we're definitely going to have to come back to this. So creating and consuming, 2 different things, right? Makes sense? To create a library, or to create a module, means that I create a file and then I export something from that file. And to consume a module means that I require the stuff that that module exports in another file. So that's creating and consuming. Node uses something called the CommonJS syntax for that, because when Node was created, JavaScript had no way to manage dependencies, which is really what all of that is about. When I have this file, it's my index.js file, and I don't want to write all of my code in index.js because that would make it hard to maintain later on. So instead what I'll do is I'll split my logic up into different files, and I will import those files into this code. And this happens across many, many, many different languages. C languages and Pythons and Rubies and all these languages, they do that, and it is built into their language. And JavaScript did not have that built into the language. And so what people did was create libraries or specifications of what a system could look like, and then they implemented that system using JavaScript, what was available. So CommonJS is a JavaScript implementation of a dependency management system. The good news is, since ES6 came out, we do have built-in modules now using import and export syntax. But we won't worry about that until week 7, OK? Cool? So we're going to focus on module.export. So we're going to be doing node exports and node style require imports. Now, again, Node didn't come up with this. They used the existing CommonJS format for that. All right, and then there's a bunch of details here. But it probably makes sense for us to create a new package, right? So I was thinking about creating a calculator. I know it's kind of boring, but simple functions, right? What kind of simple functions would we need for a calculator? Something that can add two numbers together, that would be useful. And what else might we want to add to this calculator? We can make it as simple as we want it, but let's make it a little bit more complex than just adding. Exponents, yeah, that's a little too complex maybe. Maybe not. I mean, we could do that. That'd be an interesting calculator, addition and exponents. OK, maybe we'll add one more thing. Sorry? Max? To find the max of, are we able to put a list of numbers in maybe? So if we put in, let's say that we write a calculator where we run the command line tool. We can give it an action that we want it to do, add or max, for example, or like a power of or exponent, and then we can give it a list of numbers, and it will perform that action on those numbers. Maybe we can try that. That might be ambitious, but we'll write tests for it, and that will help us deal with that problem. Because I'm not going to go and do all of that from the top down. I'm going to start from the bottom up, and I'm going to start by writing the function that knows how to add things, and I'll write the function that knows how to figure out the max of things, right? Now, I might just use some built-in JavaScript, or we'll just ignore some of that library stuff that's built into JavaScript. Just talk and say, yeah, this is how we would do it with JavaScript, but we'll write the function that does it so that we get some practice writing functions that are familiar using tests. Does that sound? I think it sounds good. You do have a bit of a choice. So if you have any ideas for things you want to add to this software as we're doing it, please put up your hand and let me know. All right, so this is the folder I'm in. I'm going to create a README file. And I don't really do much with them, so I'll leave it there for now. I would love to give you better notes, but I'm just horrendous right now. I'm going to make a directory for my project. And in the project, I will go inside. I'll npm init it, so this will become a new project. I'm so lazy, I don't even want to hit enter repeatedly. So I'm going to say -y, and it just does it for me, right? This is nice. Good. Quick wins. Now, I mean, you might end up with stuff you don't want, but I can always change this package JSON later, right? So I'm after the template, then leave it to me. Right, I got my package. I'm going to make a new directory, and in my directory, this is going to be a module that has a source directory. I like to do that. I like to put my code in a source directory, but you could just leave it out if you want. And in my source directory, I kind of have to figure out where I want to put my tests, because I could put my tests right next to my code, That means that I have a add.js file maybe and an add.test.js file that performs the tests on that. I could write the tests in their own folder. So I create a folder called __ tests, and I put my files in there, and it'll find that folder for me, and it'll run all those tests for me. And that would separate it a little bit more. There's not just one way to do this, so we kind of just have to choose. But let's see what Mocha says about it. The fun, simple, flexible JavaScript test framework. Okay. Like I said, I use Jest, so I'm not as comfortable with the documentation here, but they list out their features. That's good. They got some test coverage reporting, support in the browser. That's super powerful. We don't care about that today, but that's cool. That's cool. That means that you might get your test output actually rendered in the browser rather than in a command line tool. That's pretty sweet. Installation. To me, that sounds like the first step. Getting started will probably be the next one, right? So that's what I'm looking for in these documentation is just some sort of a guide that says this is kind of where you should start. And once I've gone through that guide, then I jump to the API section. I start to read a little bit more of the details and the technical stuff. But I like to go for something that's new to me. I'll just start with this. And so here they're saying we have two options, and I'm curious if we all know what those different options are. What is the option? What are the options here? What does that do for us? Okay. Cool. Yeah. That's great. That's a good. I'll talk about for Calgary. I'll try and. Yeah. So here we're saying we've got we can install Mocha globally, and that means that we're going to install it one version for our version of Node. If we're on version of Node 8.9.4, then we'll install a version of Mocha for that version of Node. And anywhere in our command line, if we type in Mocha, it will be able to find that and run it. If we were to save Mocha instead as a dependency of our project, then we would only be running it within that project. So I'm going to show you an example of both of those because I can easily install and uninstall it globally. I'll show you that. The last little thing here, we've got the save dev. So save dev versus just save. That is also a different consideration. So we'll see what that means and why we might do that. Mocha is a development dependency, right? It is not code that our end user actually uses. It's code that makes sure that that code works. So we don't really want that. We want to separate these things and identify which code ends up on the user's machine that they run, and what code is it that we just run while we're in development. So I'm putting all my test code in there, all my build pipeline stuff, anything that's for development, I'm putting it as a development dependency, and then I got a real clear, nice looking separation of that. When I go and install this code in production, it won't bother installing my dev dependencies into Node modules. So I can save some time in terms of how long it takes to install a project. Because these things are actually pretty big. Things like Mocha and Jest and all these libraries that help us with this, they're applications. They're not libraries. These are applications delivered written in JavaScript, delivered through NPM. But they're big, so it'd be nice if we just didn't install them on our AWS servers or our DigitalOcean servers. So that's why I like to do save dev for that. Okay. So if I am in here and I type Mocha, I get command not found Mocha. And if I say which Mocha, because that's going to tell me which one it would find, it's definitely not found. That's confirmed. So I will npm install -- global or -g, right? So -- global. Typically, command line arguments, if you're going to use the full word, you'd have 2 hyphens before it. If it's a shorthand, like just G, you would see 1 hyphen before it. It's kind of a convention. I actually have not. If anyone knows, I'm sure there's someone who knows better than I. But if I just do global, that will work. And I tend to do this in practice, -G. I don't install a lot of libraries or node modules globally. I prefer to install most of my node modules for the package. There are a few that I install globally. Mocha is not one of them. But now that I've done that, it says no test files found. So I could go into any one of my projects now, and if there were test files and I ran Mocha, it would find them. Well, I think I might need to just tell it a little bit, maybe give it a bit of information. But let's say that I have a project from 6 months ago and a project 6 months from now, and there's these two projects that exist on my machine. I mean, projects can't exist from the future, but I got these two projects. And one uses Mocha 1.0 and one uses Mocha 2.0. That's a reason to install them specifically for those projects and not globally. Because if I install it globally, I get to choose one version. And if I want to switch between projects, I need to npm uninstall -g mocha at 1. I can actually specify the version, so I could tell it, let's get rid of that version. And then npm install -g mocha at 1. Now I can go work on my other project. That's not really what I want. So instead what I'll do is I'll make sure that I am in my project directory. It just has to be somewhere that is within that has a package JSON above it. So now that this has a package JSON that is accessible, I can npm install Mocha. Actually, I'll just do the save dev. So npm install save dev Mocha. That's going to install it locally into this project. Now, if I type Mocha, it tells me Mocha is not found, and I expect that because I've not installed it globally. I've installed it for this project, but we are not adding this project's node module binary directory to our path. Does that sentence confuse people? We are not adding this project's node module's binary directory to our path variable. Anybody not know about environment path? Okay, cool, thank you. I just want someone to, because I don't want people to sit there not knowing what I'm talking about there. I can do this in export. When I export, I get all my environment variables out there. I really hope I don't have anything private in here. Probably shouldn't keep anything private in here. There's something called path. This is how my machine figures out where to find those executables like Mocha, for example. So when I look here, I can see that I have a path in here that ends with node version 10.16.3 bin. That's where global node gets installed to. And so that's why when I install a node globally, I can type Mocha and it finds that tool for me. Okay? Excuse me. So that's fine. When I say I'm not going to add every project's bin directory to my path, it means that I'm not going to go and actually prefix this with, well, users, K. Jensen, sync, learning, LHL, V3, lecture, week 2, week 1, Mocha notes, project / node modules / .bin. That's how I would finish that off, right? So if I put that whole thing into my path, then for this project, I could just type Mocha and it would run. But we have better ways. Package.json helps us with this. So I can't type Mocha here, but if I edit my package.json and I go down to the test script, and I put in Mocha here. Sorry? Like dot? Oh, here. Yeah, okay. So let's do that first. Let's say node modules .bin /mocha. That runs. So if I actually find that in this project, that executable, and I run it, it finds it fine there. If I type npm test now, which is actually the name of my script is test, I'll go back to it so you can all see that. If I run npm test, it also runs that command for me, and I didn't have to type node modules.bin mocha every time to do that. That's a bonus, right? So now I type npm test anytime I want my test to run. And we think, okay, well, that works fine because we put node modules.bin in there. But the great part of it's not the great part, actually, it's a pretty insignificant one, but you should know about it, is that I can just put the name of the executable in there, and it knows that since I'm running this project's package.json, it should temporarily add that path for me, run mocha, find it, and then not have that in my environment anymore. That's how this tool is working. All of this extra stuff that's happening when I do npm test is a little bit of the npm program making your life easier, making that path available, running mocha for you straight up. And so in your scripts up here, you do not need to actually prefix it with node modules.bin. That is implied when you're doing this. If for some reason you're running some other executable, you might need to fully qualify it in here. But that because it only adds that node modules.bin folder for this project in temporarily. Okay. So any questions about this file before we move on? What about the scripts? Does that make sense?
That means that I can just like make up my own, right? Like I can make a script where it says test with ASDF and it calls whatever program module I want.
ASDF, echo, ASDF, I think. See? I don't know. So yeah, this is a really nice way to make sort of shortcuts or aliases for you for this project specifically. I use this quite a bit in my projects. I'll do it for making sure your database can be set up. You just type in one command, npm db setup or something like that, and it just does what it needs to so that as you share this project between developers, they don't need to know the magical incantations. They just need to always look at package.json. When you go to a new project, go and look at package.json. Look at the script section. It gives you a lot of information about what people intended you to do with the project. You'll find things like, well, test is a really good one. That's why they do it by default. Build, we don't know what that does right now, but that's OK. You might have one for dev server. I want it to run my development server, maybe my prod. So I'll run my server, but in production mode. So I might have a few different scripts for that. Maybe I'll do db setup. So all these scripts that I just added, build, dev server, prod server, db setup, I've named them myself, and I need to type npm run and then the script I want to run. The only ones I don't need to do that for that I use are start and test. I can run npm start and I can run npm test, but I have to npm run local or npm run build or npm run dev server. Does that make sense? Okay, it doesn't know about all the things we'd want to do. So the ones that we customize, we have to use the run command. Oh, come on. Okay. So now I've got this project. I may as well bring it into VS Code because it's a bit nicer to work with. All right. So back to my documentation, right? I just installed this thing. We talked a lot about the differences. I hope that's clear now because we need to make these decisions ourselves as we go forward. And hopefully the documentation does talk about these options. But keep in mind that even if the documentation does not say specifically that you can install it globally, like packages can be installed. You just use -g, you can install it globally. So the documentation might not want you to do that, so they'll just leave it out. But the tool, how do you use it, is actually up to you. So as we go in here, we get started. It's saying make a dir called test, and put test.js in there. So let's start by doing that. Maybe I will make this directory beside my source directory, test. And inside here, I'm going to just do add.test.js. Now, I've named that add.test.js because it tells me that it's a file that contains my tests. It's also in a test directory. That's going to help the test runner find it. Actually, both these things would help it find it. I kind of like it because if I start to get more and more files up here, I want to know which ones are the tests and which ones are the implementations. So that might be why I do that. As we come down here, we are seeing in my editor, I can require this thing called assert. So let us copy and paste this just like we should do if we're learning this for the first time. Now, I'll just take that test, and I just want to see what happens. So I ran the test. I no longer got the previous error, which was cannot find any tests, right? So now I've got this folder. It has tests. It's going to contain my test suites. And let's look at it from this side first. I mean, this is kind of cool. We know that this test is testing a function called index of. Is anyone not familiar with index of? Okay. And it should return -1 when the value is not present. So what that's saying is that otherwise, I think index of returns the index, and it can't use 0 for not found, right? Because that's a valid index. So instead, it uses -1, and we suffer forever for that reason, right? Because it's just a pain to work with. There are lots of stuff I don't know. It's too bad. But there's interesting things you can find out about all of that. I'm going to go in here and take a look at how they've actually implemented this. So let's side by side is really tough for me because of the size of this zoom. So I'm going to try my best here to. OK, I think that works. Because this is going to allow us to look at the difference and how each of the stuff in the output is created by our test files. So when the test runner runs, it's running the array tests. We see that in the output. It ran the array tests. And so how did the test runner get that information about that we're running tests about array? Sorry? It's in the describe bracket, right? So if we put that in the describe bracket, then we're categorizing these tests as tests for an array. So that's good. We've got our header there. That's it. It's that simple. We can nest these describe blocks. And that's what we can see on the second layer, which is where we're seeing index of. That is also coming from a describe block. It just happens to be one level down. So what I'd expect is to write maybe a few more tests for index of, and then I do a describe where I write tests for find or map or whatever function on array you want to do, right? Splice or slice or. And they've got this kind of convention here. I don't know. This is kind of interesting. I think this means it's a function they're testing of some sort or some. What are they doing here? Yeah, like some instance method of the array. Don't get too worried about that. We're just trying our best to describe what they mean. So again, this is like naming variables. We get better at it as we frustrate ourselves more and more in the future, right? The last thing here is, we got this green check mark. What does that mean? Yeah, great news, right? That's what we love. And we can see that we had one test and it's passing down here, so green and green. But this is the description of our test. And I would argue that this is one of the most important parts of our test definition. Because the describe, that's kind of cool. But when the test fails and we see a list of 30 tests and 29 of them are green and one of them's a red X, with a good description, we already know what we want to do next, right? Without a good description, we need to go figure out what that test was for in the first place. Read the code from 20 years ago, maybe. No, but from maybe a few months ago, which is like 20 years in development time. And then figure out what it was supposed to be doing. A good description helps us make that problem less. Make that a lesser problem, I don't know. at the end, this is how we verify that things are good. And the reason why we got the green check mark is because when we run this code, which is calling index of on an array, the index of 4 is not in the array, so we get -1 back. And this is how we tell it what we want the value, what we think the value should be. We expect it to be value 1. And if I am not very good at this, and I think, well, sorry, it's not fair to say that. If I don't maybe fully understand the index of function, and I make an assumption that's incorrect, and I think that it returns 0 if it doesn't find anything, or maybe false. Maybe I think it returns false in that case. So let me run this test now. So I get this error here. The test failed. It says, oh, I should return -1 when the value is not present. It's failing. Why is it failing? I can get some information about that. If I were just to run my function, I mean, that doesn't really, might not tell me that. This is an error based on the assertion. I created this error because my assertion did not match. Whereas it's slightly different from a different type of error. Whereas, so let's see what it says. Assertion error, -1 equal to false. That is not true, so it fails on that. I go back in here. I can say -1. Come back, run my test again, and now it passes. Great news. Right, so what happens if instead I say that -1 is equal to not existing var? Not existing var is not defined. That's a different error. Right? So some of our errors are triggered by JavaScript failing to execute, and some of our errors are triggered by validations not passing. Okay. So when the first thing you want to do when you see red is figure out which group does it fall into. Is it because my test, because the code maybe returned something and my test was incorrect? Whatever it is, we just have to that's our first point of sort of trying to isolate the problem. And that also, you'd see those if, let's say I am the one writing the implementation of this function. If my function had an error and I caused it to do a reference error, type error, or something like that, I get that in my test runner output, and my test will fail as a result of that. So it's not just that assertions don't work. It's if there's an error in general, test no good. Okay. Going back up to this bigger mode here. And this is not what I want at all. I think what I want, let's see. So we did all that. Oh, hey, ahead of the game, right? So, let's not get into those details. Okay, I think I'm done. I think I'm done with the Mocha docs right now. Yeah. So I've learned a little bit about Mocha. They have this built-in assertion. So let's do our own test using just what Mocha gives us, and we'll add chai. Actually, you know what we should do is take a break now. It's a good opportunity before we start something like that. So I want to make sure, Calgary, can I get so I know you haven't asked any questions, so I just want to say, thumbs up if you're good to take a break. Otherwise, please ask questions. We'll answer them now. If there's anything from any of you, let's do that as well. But I will definitely wait for a response before going to break. Okay, thank you so much. Thanks, Grant. Thanks, thanks, Nirali. Thanks, Andre. Oh, everyone, thumbs up. Yes. Calgary, can you hear me? Oh, I'll turn the screen on. That'll make it pretty obvious. New space. There we go. Cool. But we will wait for a confirmation from Calgary before we actually do start. Hey, check out all the great responses we got. I'll zoom in a bit too, because. Thanks, Grant. Pretty good. Yeah. Rockin'. Awesome. I hope that is an indication of how excited we all are about this next stage. So we've just run a test, right? We have not written a test yet. That's fair. We've only run a test. And it was the test provided to us by the Getting Started documentation. And so now that we have this, we need to use this to figure out what we're going to do next. So let's write a test for our add function. Right? I mean, we'll describe this different. We'll say we'll describe all of these tests are for the add functionality of our application. And here we can either use test or it, and there is no difference. They're aliases for each other. It's more about what you would prefer. So I can test something, or I can it. Oops. It. Oh, come on. It should add 2 numbers. Kind of like that. That's a nice way to describe a test. I could also say test that 2 numbers can be added. For me, the important thing is that I'm consistent. I don't interleave it and test. I choose one and I just go with it. But it does sort of give us, it's a little bit of an artifact of just people's opinions on how we should write our tests in a bit more of an English language, a nice readable way. I use it because I like this. Most of my test names, it should do this, it should do this. And that makes a lot of sense for unit tests, I think. We'll stick with that. But you feel free which one you want to use, and just stick with one if you do. One per project. You could go to your next project and say, oh, I used test last time. I'm going to use it this time and see how that feels. And then after both those projects are done, make a decision, and then you probably feel good about choosing one yourself, right? But they are aliases, so they work the same. The first thing that we pass to this function is the description, the name, the text we're going to see in the output that describes the test. And the second thing that we pass to this test is the actual test function, the function that's going to run when the test is performed, that's going to execute the code that we want it to, and run the assertions that we want it to as well. So it should add 2 numbers. Now, this is a very simple test, right? I need to call my function with 2 numbers that I know the sum of, and then I want to expect that that function returns that number that I've calculated in my head. So I do have to be at least that good at math in order to write this test. So I have to know what the reality is, what is actually true. So we're going to stick with our assert call that comes with Mocha just for this one test. And I'm going to say assert equal the function that I call and then the return value of that function. Okay, so assert equal. So I'm saying that these 2 values that I pass in are equal. My function add takes in 1 and 2. And what is it that I expect it to get back in this 3? And it's very nice to write pure functions because that's how confident we can be on what it should return. A function that is not pure is said to have maybe cause side effects, which means that 1 and 2 could come in, but 17 could come out of it because there's some sort of external force that's changing that. By writing functions that are single responsibility, that are pure in nature, that when I pass it 1 and 2, it always gives me 3, that's guaranteed, those are easier to test. So if I write more of those, easier to test those types of things. That's what we're going to stick with today. So we assert that the return value of add is 1 and 2 is 3. And it did not pass the test, right? And which category of error is this? Running the code, yes, exactly. Not the assertion. The assertion we didn't even get to the assertion yet because the code can't run. What's it telling me? The function's not defined exactly, so that's what we need. For my first test, I'm going to write the function right in my test. Later on, we're going to have it in a different file, but I want to show you me extracting that and doing the exports very small steps at a time. That'll work, right? Cool, let's do it. Ta-da, that's as easy as it can be. Now the problem is, my test is not, that just shows that my test is not very good, right? Because I did the minimum amount necessary to make the test pass. It just so happens that if I take the number 10 and 20, I want 30 out, right? Much better. So I'm not able to trick it now, right? So we have to think about that. We can't just write, one little assertion, and it's like, yeah, great, passes. Well, yeah, one assertion means you just return a static value from a function. It'll pass usually, right? So we need to challenge our functions to return under all sorts of different inputs, the different outputs that we expect. And so here, what type of an error is this actually? It's a test error, exactly. And so what it's telling me is that I expected the number 30, which is in green here. I know it's kind of out of order a little bit. But I got the value 3. And that's not what I wanted. I wanted to add those numbers together. And here it's kind of saying it's trying to check the equality of these. Notice it's using 2 equal signs, I believe. So it's actually performing not an identity check. It's just checking to see if there's equality after the coercion. So let's actually now make this function. That's not going to work, right? So let's take A and B and do what we know to be real. Run the test, and it should add 2 numbers. And now we know that it adds 2 numbers, and we're more confident in that, right? Hey, it should add 2 negative numbers. I could put that into that same test, right? I could write one big test case, expect this, and expect this, and expect this. But then I'm not getting as much information back from the test runner when a test fails. So maybe what I'll do now is split this up and say my negative numbers, what do I get out of that? What's my expected value? Sorry? I can't hear. I can't. Thank you. Okay, let's do that. So it's just, again, it's about identifying what inputs I could possibly send in and identifying what outputs I expect. Run that. Adds those 2 numbers. If I make a mistake there in my test, it definitely tells me, no, that does not work that way. Let's fix that. Good, now we're back to normal. Last week, oh, not 1, 2, that's stupid. A and B, and then return A plus B. How did we test this function last week? Right? That's what we did, right? We would just console log what this thing returns, and then when we look in the output, we would check to see if it's 3 or not. And if we wanted to do it a few times, we could set up a bunch of our tests, like so. And then when we look, what's our output going to be? 3 separate lines. Yep, we're going to get 3, 30, negative 30. And we then have to compare our output to our file to make sure that that was correct or not. So maybe what we'll do here is say, oh, I'm actually going to do a triple equals because that will work. That's what I want. Now what am I doing? True, 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 or false if it doesn't pass, right? Now, I'm asserting through this console log that these two values match. Isn't this better? I know there's a little bit more code here, but then when I run it, it tells me what I expected and what I got. And if everything passes, I just get true, true, true in the form of green check marks, right? That's why we moved here, is because people were doing, people are doing this so much that they're like, there's got to be a better way. And here's our better way. The better way is through Mocha and Chai. Okay. So before we get too far into this, I'm going to add the second piece, which is our assertion library. Let's increase our, or let's improve our ability to write assertions. And so Chai is going to help us with that. It's just assertion library. It does not run the tests. That's Mocha still. Getting started. Install Chai. npm install Chai. That doesn't seem right to me. I don't know. My instinct's like, no. Why? It's not global install because -g is the way to global install. By default, it would be a package install. Yes, but that's good. That's actually a good thing. I want to make sure we raise those things, right? Because, yeah, if I do this, it's not going to install global install for the package. But what's triggering that instinct of mine that says, oh, I don't think I want to run that command? What's the type of dependency that I'm dealing with here? Right, so if I release my package, then, yeah. Right, not the developer. Yeah, so I think this is a development dependency. So I want to install this, but even though they didn't tell me that, I don't just copy and paste that in there and say, well, they know what I want, right? So I don't want you to do that either, because I know it's week 2, so you got tons of leeway. But as soon as I see this, I'm like, wait a second, the last time I installed Mocha as a dev dependency, now I'm going to install Chai just regularly. When I look at my package JSON, that's what it's going to look like, even though these things go together like Mocha and Chai, right? That's what they say. It goes together like Mocha and Chai. Those things are both the development dependencies. I installed it during the break. That's why it's here. So npm uninstall Chai. I just copied and pasted their command in there. If I look, no longer dependency. And what I really want is npm install or npm I dash save dev or install my dependency, my dev dependency called Chai. No, that's better, right? Good thing I didn't follow their instructions exactly. But the intent was there. I've installed it. I've performed the task. Look at this. Like, what are they doing? I don't know. Maybe they. You know what? I assume that they are better at this than I am, and there's something that I don't know. It's usually the case. So, I mean, but nowhere in here do they actually say. Here they say, well, we recommend installing as a dev dependency as star, but the command we give you doesn't do that thing. I don't know. Come on, whatever. Jest? Oh, the one I use is Jest, and Jest comes with all these assertion expect comes built into it. Yeah. So I would just follow Jest's getting started and use that. And we will use Jest in week 7. So we do use a different testing framework later on. Actually, 2 different frameworks later on. Also Cypress, but that's awesome. That's down the line. Okay. So I kind of followed these tools. Good. Assertion styles. That's next. This is what Chai is all about, is providing different ways to perform assertions. And just like I want you to choose it or test and just go with one of them for this project or for your project, same thing with an assertion style. Kind of choose one, use it for that project. If you didn't like it, you could use another one the next time. And then over a couple of projects, you're going to say, I like to use it with expect. OK, great. We'll just do it then. I I can't give you a good reason to use any of these specifically. Actually, like this to me makes some sense, right? I assert that these values are equal. All of these values, I guess, at multiple values. No. Foo equals bar. I don't know what that means. So whatever. I'm going to skip that. This is actually kind of what I want to introduce people to, because I like this one. So you're going to see that a lot, right? We have opinions. My opinion is this is the one I like to use. Expect. Is anyone using expect? Okay, we got one. Great. I don't know what the assignment says to do. Doesn't really matter, because they're all going to perform the same role. It's that third stage of validation. All of them are doing the same thing, so let's remember where we are. Third stage of validation, I can either assert things to be true, or I can expect them, or I can attach a should function to them and do that kind of stuff instead, right? I like this. I think it's because of jest. I think it's because this is what I use, and this is what I have in jest. So that's probably why I'm into this here. Wow. Expect beverages. So beverages is what type of value? Object, yeah. So expect beverages to have property T. What does that mean? Yeah, so it does have it with length of 3. So cool. Wow. Cool. I love it. Because I guess what we would do otherwise in our other example, which I still have here, is something like console.log beverages t length is equal to 3. I could probably do something like that, and that's actually less typing. I am going to get a reference error if t does not exist, right? So if t doesn't actually exist on there, I'm going to get a reference error. So that would be the type of failure I would actually have. Whereas with this code over here, I expect it to fail on the assertion that that property exists. So it actually gives me that information back. I'm like, okay, no, it doesn't have the property t. It's not because it doesn't exist there. It's because I expect it to be there, and my assertion library is not finding it. So kind of up to you, whatever you prefer. But these tools become quite powerful. And then what I said as well is you got plugins. So if we look at something like HTTP, let me find a good example. There we go. I know this part doesn't make a lot of sense yet. We haven't done web servers yet. But here with our web server, we're going to make a request to this web path here and send it this information. And when it comes back, we expect that there's no error, and we expect that it has a status code of 200, which means everything's OK, right? So I don't know if I should be doing that anymore. I'm mixed on that. Sorry about that. So Chai's helping us here test our request library, which is a more complicated piece of code to work with. But with this plugin, it becomes easier to deal with. We can write our expects without having to expect that response.status code equals 200 and remember that all the time. This might be easier to, it's nicer to read. That's kind of the goal there. So I will install Chai expect. I guess as soon as I install Chai, I have the option to use any of them. The way that I import this is instead of the assert library, I will import expect. Hey there. Wow, who wants to be doing that job right now? It's wet and high up there. That's someone cleaning the windows. Someone cleaning the windows out there, respect. So this is how I'm importing this library now. What I've done is I've imported Chai and then immediately pulled a value off of what I expect to be an object. So I could say, let's do long form, import Chai or require Chai, and then var expect is equal to chai.expect. Okay, cool. So that's like week 1 style, right? I import this library, but then I need to grab, because I could do chai.should and I could do chai.assert to grab one of those 3 if I wanted to. The one I want is expect, so I grab it off of this thing here. Chai is an object. I mean, console.log chai. Here's chai. It's chai version 4.2. So that object has a version attached to it. It has a should function attached to it. It has an expect function attached to it. It has this assert with a whole bunch of sub-functions. So this is what's coming back, and what we want is just this one little thing out of it, out of this library, this module we're importing. And so because it exports an object, we have access to a whole bunch of different things. We grab expect, and let's switch these over. Expect add to B3. I think that's what we'll do. This is why I wanted to do it before we went and wrote a bunch of tests, right? Okay, something like that. I don't know. Let's see. Let's see how it works, though. Oh, okay. Yeah, that might be how it is. I think what I was used to. Yeah, I'm used to another one, but I think it's 2 to B. But that's where we want to go in here. We want to find our API. We find expect. Yeah, 2.b looks like it. So this thing called chains. I expect, and then I can chain a bunch of other things together to ultimately get the configuration I'm looking for. So here's some examples. Expect to not have property, or expect to be an array, or expect to not be an array, or expect to not throw, or expect to throw. Those are things we can do. Expect to not equal 1. They're saying not recommended. Okay. With great power comes great responsibility. I think that's motivation to go read some of these docs for all of you. So I'll let you do that. Let's find assertion styles. Expect. I think that's probably what I meant to do, was equal, to equal. Because to be a string, that I could test type on that. I could test what type of a variable a value is. So making sure, for example, that the values passed in are numbers, for example. I mean, we've dealt with stuff last week where that might make some sense. So it's actually to equal Sorry for throwing you off. Again, I don't use Mocha and Chai directly very much, so I just kind of went with what I knew. That test is passing now. The assertion library that we're using, that makes sense. So what I probably want to do now is, and any other tests you want to write for add, I mean, there definitely is some I can think of, but we should move on to another file, write another test, and then pull this stuff out and put our calculator together a little bit more. Okay. So here, we were going to do max.test.js. So for this, I'm going to first import my expect function. So I import chai, and on chai, I grab expect from it. Then I will describe the test that I'm running. This one's for max. Give it a function, put all that stuff in here. All of my tests will exist in here now. It should return the largest number. And this is where I have to start expect maybe max 1 and 10, 2 equal 10, right? And then what's another test? I want to put at least one more in there, so I can't. I guess I can always do. Well, no, I can't really. I guess I can say if if the input value is 1 and the output value is 2, return 3. If the input value is 10 and 100, return I can do a bunch of if conditions and make that pass still. But I think at least 2 assertions makes, I'm not going to go and write all that logic, but I guess you're trying to get, what I'm trying to get at is I'm trying to write the minimum amount of code, but my test needs to keep me honest. That's the message. So this will equal 100. Actually, maybe for this one, what I would do is give it them in the other order here to make sure that the order of those arguments doesn't really matter for figuring out which one is bigger. Okay. So what's going to happen when I run this? Okay, cool. Yeah, failure due to the function. I get 2 tests passing though, right? So my 2 test suites run. Add runs, both those tests pass. But my new test doesn't run, or it runs as well under max. It does not pass, and as expected, we get the max is not defined. So thank you, everyone. That was good on that. Now, instead of writing this function in here, I'm going to create that in its own module called max.js. And this function max will take in 2 values. And just for the sake of time right now, because I'm not, it's not about the solutions to these problems. That's not what today is about, right? So this function now exists, right? And if I run my test, still doesn't work, what do I have to do? Yeah, it's time to create and consume those modules, that module. So the idea is I can export export defaults. What is it? Module.exports. My bad. I use the newer form, so it's still module.exports. It's, you know this better than I do. There we go. The only thing that this file exports is what? Max function, exactly. Now what does this function export? That's right, kind of like chai exports a function with a bunch of, or an object with a bunch of functions in it. This is how I can export multiple things from one file, as I include them in an object like this. And if I had, in this case, it doesn't make much sense. It makes sense to only just export that one function. But if I wanted other functions in here, well, then they could also come in here and do that, right? And I could declare these things right in here. However you want, that'll kind of work like that too. But I don't know, I'm trying to make this easy on you. So the only thing this exports right now is the single value of the function object, right? Max. So I'm exporting that, and now here's where I need to require that. Now, how do I import a file that I created? Because with chai, it was really easy. It knows that these libraries I install, it knows to look at them in the node modules directory. So if I don't give it a relative path, it goes and looks in node modules. But now I need to find a file. I need to import a file that I created. Yeah, and so normally that starts with where I am right now, maybe, or go up a level. And so this editor is helping me out here. I can't promise that'll be the same for everyone. If I do add or /, it's telling me that the only file I can find is add.test. So that must mean it's the file that, or it's the folder that I'm in. What I want is to go up a directory, and if I do that, then there's a source directory, that's the one I was in already, test and node modules. I want test. Then source, my bad. And this one gives me max. So it's saying, oh, it found this file called max. I don't have to, but I will put JS. Actually, I don't think I have to put .js. I believe it resolves those common name or extensions itself. But in this case, I'll just say max.js. So I've imported this file. This should now be that function. And if I run the test, all passing, right? Hmm. Oh, yeah, that's a good question. So the question is, if I didn't give it this path here, and then I created another one in here called, well, it doesn't really matter as long as it's not .js, right? It's kind of the point. Yeah, so as long as it's not .js, which one does it find? Does it fail because it can't figure it out? It's smarter than that. JavaScript is what it's looking for. TypeScript is what it's looking for. Those types of things we can have. Node can be like, oh, I'll look for something called max.js. If it doesn't find it, there's a priority. It'll look for that first, then it'll look this, and eventually get to the end and not find it. But it's not going to be like, oh, well, then we'll load max.text. Probably not in the list of things it looks for. Finds it just fine. And if I deleted max.js, I believe that I would get a warning about not finding the module. I don't think I would get a bad, like it tries to import a text file incorrectly. It doesn't care about text or markdown in that case. Yeah, that's my expectation. You'd have to test that specifically, but. Okay. So here's my max test. Here's my add test. So these two things are unit tests, right? I've verified that I can add two numbers together. I've verified that I can find the max of a number. Maybe I want to try a few more in here. It's just about building confidence. If I think of something that I missed, or here's the best time to write a test. I just found a bug in my code. And then we write a test to verify that bug never comes back. That sounds like a good way if you're not sure what test to write. That should always trigger. It's like, maybe I should write a test to make sure this doesn't happen again. And also, if I test that max works and I test that add works, well, when I go and start to use them, and something goes wrong, chances are it's at the integration point that I've made a mistake. So my unit tests are telling me that these functions work independently, but when I actually go try and add them together, I still have some work to do. So I'll take index.js here, and I have to var require or get my add function into this file. Uh-oh. Problem, right? Where's my add function? Yeah, and this is why we don't do this, because this code doesn't belong in here. I just did it to show you it's possible. So in this case here, what we need is to create our add.js file, and this needs to module.exports add for us. And then in our test for that, I'm actually going to put this back up here, make it consistent, and get add from source add. And now I made a small change. Test, expect is not defined. Okay, that's better. Now it passes. So my mistake was that I didn't rename this, but running the test was a fast way to figure it out. Actually, Mocha watch mode, I don't know. See. Double minus watch, thank you. That's the. Now we can see that I've not been returned back to my command line. So if I take this test over here, and oh wow, gonna lose a lot of space. But I make this mistake over here, save it. That's instant feedback, right? NodeMon's cool, but this is where it's at. Okay, so I'm going to go back, but just know now, every time I change my code, my tests are running, and if you hook into one of these monitors, it's really easy to have those things side by side and just get addicted to it. Better than coffee. Okay. Test passing, better than coffee. I don't drink coffee though, so I've exported both these things. Now I can import the add function. Maybe I'll just leave that out here. Great. And the max function. And I want this function calculator. And it's going to take in an action and maybe also, in this case, we're only going to take in 2 values just to keep things simple for ourselves, because I don't want to talk about variable arguments and all that kind of stuff right now. But let's say this calculator takes an action and the 2 numbers that we want, and it will tell us whether or not, yeah. We got it. How do we get that data into this? Yeah, so we'll call calculator. And we expect that calculator, maybe we'll have our get arguments function, and that will return process.argv.slice, I think, right? Slice 2. So now we know that the first value of get arguments, if we var arguments get argument. So I'll do that. Now arguments 0 is which part of that is action, yeah. So arguments 0, arguments 1, 2. And what the calculator will do is, if action is add, then we will return add A and B. And if action is max, maybe we'll do return max A and B. Tell me if I'm making a mistake here, right? I'm just ripping through this. I'm not even thinking about it. Throw new error action unsupported. Cool? Awesome. Now I gotta leave my tests. Action unsupported. Good. That was an okay test, right? Now every time I run this, if I don't give it an action, it will throw me this error. And if I give it the action add and the values 1 and 2, wait, I haven't console logged it, right? That was my mistake. So I'm building up this test structure. Oh, that's, why is it that it came out with 1 and 2? Yeah, it's concatenating 2 strings together. We could write a test to make sure this never happens again, right? That's what we want to do. When we see that and we're like, oh, that shouldn't happen. Well, how do we, maybe now's the time to write a test for this, because we're already running into problems. So I'm going to go in here, calculator.test.js. This is going to be our integration test. We're going to test that these units are working well together through the calculator function. I will describe, I guess I got to bring in with jest I don't actually have to import my expect function. It's a global just like describe and it, but I will keep doing it. So there we go. I will describe the calculator, and I want to should, in this case, accept parameter arguments. So it should, first thing, throw an error if no action is supplied. So here, I've got this calculator function that I'm going to run. And I want to verify that when I run it without passing an action to it, that it throws an error for me. Because that's what we saw in here. So maybe I'll just add that to my test suite so that I can get some of this good stuff going on, auto reloading and all that, right? So here we go. Expect that the calculator function that's going to be required from the source index. Maybe I would put that into its own module, kind of up in the air, but up to you. expect calculator with no action. Okay, so I'm calling that function, right? And then I got to go over to chai because I've never done this before. I'll go to my expect and should throw. So I just search for throw. Gives me that. And this function definitely throws an error. So here, bad function, expect to throw. Okay. So when we call calculator, we expect it to throw an error, right? Oh, it ran the test automatically for me, and it failed. Why is that? So we're getting this error action unsupported, but that's not being reported by the test runner. Who ran this function? Who actually triggered the calculator function? I know Robert knows, but. So I call the calculator function, and then I expect the return of the calculator function to throw. It's not going to work. In order for the test runner to figure out whether or not an error was thrown or not, it has to call the function for us. So this is a situation where we might need to really pay attention here to this documentation. What am I passing it here? I've not invoked this function. I'm passing it the reference to the function so that it can invoke it. So if I do that here, let's see, 1 second. What does that know? Let's double check. I expected. Oh. Did I export it to you? Oh, one thing I need to make sure I do is export from that index file because I'm importing this calculator function so I can test it. The thing I did forget, which is it's not quite standard to export from an index like that. So it feels a little bit weird, but I'm just going to keep going with it. As long as I get that function out of there. Calculate. And, well, So what I'm doing here is, oh, wait, of course. Yeah. So what I'm doing now is I'm passing this function to Mocha, or Chai, or whatever. And Mocha or Chai, when they run the test, will now execute this function. But they will put it in a try-catch block so they can check to see if an error was thrown or not. And then they can check the assertion. So here, we're actually passing a reference to a function that holds the function we want to call. It should still work. But actually, I'm not sure why. Test failure here. Oh. There we go. I wanted to remove my old test code from the file, because that's what was actually failing. The error was being thrown right here. So that's what got in my way. So as soon as I get rid of this test code here, which I don't really want, yeah, I guess it makes a lot of sense now to pull calculator into its own function. So this index.js file is the one that we run when we want to run the app, but it never gets run when we run the tests. It's all the other individual functions that get run through our tests. That's probably what we want to do with something like this. But I'm gonna focus on it being. Yeah, I'm going to just focus on the test for this. I'm not going to actually worry about all the process argv and the inputs and all of that. I'm going to focus now on just testing out this function and making sure it works. So it should throw an error if no action is supplied. That makes sense. When we run, so here we want to do, it feels a little bit like duplicated work. Should add two numbers when the action is supplied. So here we're not going to do, we're not going to trigger an error, so we don't need to do this to throw. We can say to equal, and we want the number 3 to come out of this when we add 1, and 2. Now, that's expecting that we pass numbers into it, right? So we will come up with a way also to make sure when we pass strings it works as well. But for right now, that test is passing. And if I want, I can do the same thing as I did before. Get 2 values out of it. That's still passing. Now what I want to do is add, oops. What happens if I give it the string 1? Because it'd be nice if I, maybe if it just didn't care. I don't know, that's a design implementation decision. Now it's failing, right? So I've hit this failure, and it's saying, oh, I expected 12 to equal 3. That's confusing. 12's down here. What have I done to myself, right? Just the fact that these strings are being added together makes it look like, okay, well, what I really want is 3. We all know why this is happening, right? So we can head over to our add function here, and we can say, passes. Describe general functionality of the calculator will go in here. And describe some more specific addition down here. And that's where these 2 tests will go. And then I'll describe max. And in here, I'm going to be, like, once I've written some tests, I'm going to be copying and pasting quite a bit. It should return, should provide the highest value when so should provide the highest value when, what did I do in the second one? Add 2 numbers when the action, oh, I didn't, so here I'm rushing. So I didn't actually give these different names. When 2 strings, should add 2 strings when the action is supplied. So should provide the highest value. Yeah, something like that. I don't know. But I would, these are all, this is the specification for my application. I'm deciding here what that functionality is, so I can make these decisions as I write tests. That is actually the test-driven development philosophy, is I'm answering questions about what this application should do as I write the tests, and then I write the code that satisfies those tests. And so maybe here, when I get 1 and 2, I definitely get 2 back. I should get 10 back for this one. And then down here, I still expect to get 2. I still expect to get 10 back as a number in that case. So it looks like it's passing. And my belief is that that is because my implementation that used the built-in math.max, it supports that already for me. But my test confirms that my function does too, because the implementation, at the end of the day, when we use that max function, the implementation is not as important to us. We simply care that the max function works. So I could write that, and then if I wrote that myself, I might need to convert those strings to numbers first. And then this test, if I were to go write a max function and refactor, because that's what that's one of these things that we get out of this, is I can right? Else, and then at the end return, doesn't really matter because they're the same, right? Something like that. But now it's failing because that string 2 isn't working. And so let's say that I refactor this without tests. Am I going to test that? Am I going to think about that as much? I hope so, but my tests will guarantee it. And now what I can do is get back to working code. And with high confidence, right? Okay. So that marks, thank you, Nirali. I did negative number export. I think we probably covered that, and I'm sorry for missing that message. I was just so entrenched in the testing of this. I will upload this code for all of you to GitHub, and then you can have it as a reference. Yep. To group your tests, yes. Yeah. So yes, the question for Calgary is the describe there so that we can break this down, and that's what's happened here. Is all of my tests for my calculator are in one describe block, but inside that describe block exists 3 other describe blocks: one for general tests, one for addition, one for max, and then each of those have their embedded or nested tests as well. Yeah. Cool. I think we covered everything on that page. Practicing unit testing, I think we did that. Definitely did some TDD. We used Mocha, we used Chai, and we created modules. So I think we're prepared for the assignments today, which is where we're actually going to gain more of an actual understanding of this, right? Again, I want to show you what's possible, what we do, but the activities help you lock it in more. Cool. If there's nothing from Calgary, if there's nothing from all of you, then I will end it here. And it's on time. That's a rarity for me. Thank you.